Okay, welcome back. Now we're going to continue on with the section on the antennas. And there isn't that much to cover today since we studied a lot of stuff yesterday. So the first thing we have to look at is the concept of wavelength when we're applying them to antennas. So if you look at the antennas like this dipole, we often use what we call a half wavelength dipole or a half wave dipole. So remember in the last video lecture, I told you how the wavelength of the length of the antennas is related to the wavelength they operate on. So with the half wavelength dipoles, actually they're half of the length of the dipole equals half the wavelength that it will transmit on. So for example, if you want a dipole that transmits on the 20-meter band, you can get a half wavelength dipole that's 10 meters, I believe, and then that will operate on the 20-meter band, because it's 10 meters and it's half wavelength. So that's what we mean when we talk about antennas that have different wavelengths. And now that we know that, we can look at a sample question and we can learn a little about how to answer some of the questions you might get asked on the test. So the sample question asks, what is the approximate length in inches of a quarter wavelength vertical antenna for 146 megahertz? And we have a list of choices here. So for this problem, there are a couple handy little tricks actually to figure out the answer. And there's an equation I wrote up here on the board. What you do is you take the frequency and you do 234 divided by frequency equals the length in inches of the quarter wavelength antenna. So how do you remember this equation? Well, just remember the number 234. 234, it's, the numbers are all sequential. 234, it's almost easy as 1, 2, 3. Except, it's not 1, 2, 3, it's 2, 3, 4, because, never mind. All right, so for half wavelength antennas, what you do is you multiply the quarter wave. You basically use the same equation here, but you multiply it by 2. So you use this equation, but then you multiply the quarter wave number by 2. And if you apply this to the equation, you get the equation 468 divided by frequency, and that's what you do for a half wavelength questions. So if the test asks you a question like this one, what is the approximate length in inches of a 6-meter half wavelength wire dipole antenna? So the first thing you have to do is convert this frequency. You have to convert the wavelength into frequency with the equation we learned earlier. 300 divided by wavelength equals frequency. If you do that, 300 divided by 6 meters, you'll get the number 50. That's your frequency. Then you can plug it in here. 468 divided by 50 is approximately 112. And if you'd rather not do math and you'd rather just memorize the answer, because there are so few questions on the test about this, you can actually memorize the answer. There's another trick just for pure memorization. Look at the number 1/2. Look at this question again. 1/2, if you look at it from far away, sort of looks like 112. With the 1/2, it sort of looks like 112, which is the answer for this question. So you can use that trick if you can't remember the answer. All right, so we're almost done. There's just a few more things we're going to look at now, and we're going to especially look at 5/8 wavelength antennas. So these 5/8 wavelength antennas, they're really great for mobile operation on VHF and UHF, meaning if you want to operate VHF or UHF in your car. And the test might ask you why these antennas are so great. What makes them so great to use with mobile operation? Well, these 5/8 wavelength antennas, they have a few things going for them. They have low angles of radiation. Low angles of radiation. You can look in the Gordon-West manual if you want to know exactly what this means. They also have high gain. We're going to explore gain in a minute. And they have better coverage, meaning they can get to other locations very easily. So what's this thing here, high gain? You probably don't know what this means, and that's because we actually are about to get to that next. So I've been saying a lot in this course how gain sort of means volume in ham radio, but when we're talking about antennas, this is no longer true. There's a special meaning for gain when we're talking about antennas. And gain for antennas is actually sort of complicated and technical, but I'm going to do my best to explain. So say you have an antenna like this dipole, okay? So you have this dipole antenna. When you compare this dipole to a theoretically perfect omnidirectional antenna, like what we call a reference antenna, an antenna we can use for reference, how much stronger does your antenna receive a signal that's coming from a certain direction? So for example, say a ham's transmitting from over here. How much stronger, compared to a perfect omnidirectional antenna, how much stronger will the signal be on this antenna from here as opposed to just a normal, perfect, theoretical omnidirectional antenna? And that's the concept of gain. And I know that's sort of complicated and hard to understand. If you need some extra help, obviously look at the Gordon-West manual. That will help clear things up. But don't worry too much about it. There's only one question really that asks about this. So you can just study that in the manual. And finally, the last thing we're going to look at, continuing in this line of thought, is with mobile antennas. Mobile antennas. So when you're mounting mobile antennas, you might be wondering, where do you put them? Like, do you put them on the trunk of your car if you have a sedan? Do you put them on the roof? Some people sort of mount them to sliding doors on minivans. Where do you put the antenna so you can operate in a car? Do you have the antenna inside the car? No. So usually what you want to do is you want to mount mobile antennas, you want to put them on the center of the vehicle's roof. And the reason for this is because when you do this, it provides the most uniform radiation pattern, which is good. So what this means is the uniform radiation pattern, that means that it radiates radio waves equally in all directions. So if this is the antenna, it will radiate equally in all directions. Uniform radiation pattern is what we call it. So the problem is if you mount it near the edge of the roof, then because of strangeness with the way ham radio works and radio waves work and antennas work, if you mount it near the edge of the roof, you'll result in a sort of a lobe in the radiation pattern. So meaning in plain English that the antenna will actually radiate more strongly towards the direction of the roof and not as much away from the roof. So it'll be, instead of being, uniformly radiating like this, it'll be kind of like, ooh, a lot over here and just a little over here. And that's not good. We don't want that. So for that reason, we mount the mobile antennas in the center of your vehicle's roof. All right, so I think that's the last question we have for this section. We are all done with this important section on antennas.